Hi, this is Mr. Huff, and this video is about the second portion of the final presentation. I'm choosing about 10 components for each one of these videos. So this one is going to include the design criteria memo, parameters, product specifications, STEM concepts, your survey and your survey results, your notebook sketches, pictures of the model, and then your technical drawings, both isometric and orthographics. All right, so the design criteria memo. Let's go just look at the examples that I have here, and I'll include these examples on Canvas for you guys. So the design criteria memo, I just want a screenshot of what you wrote in, or the little template that you used and filled in and sent, and then copy and paste the content. Notice this is too hard to read. Copy and paste the content and place that here. That will help you establish kind of what you need to talk about on this slide. So you wouldn't want to read all of this. You would kind of hit some highlights about like this introduction. You don't need to go over the proposal again, but you might talk about the function and form, the ergonomics. So basically this is outlining what it's going to look like, how it's going to perform, some of the things it's going to do, some of the design decisions that you've already made, okay, at this point, before you even start really developing your final prototypes. Okay, so you're just kind of laying out, this is what it's going to have to look like, this is what it's going to have to do, these are some of the things we're trying to accomplish, okay? And also at the end, how much is it going to cost? Again, if you did this assignment well, then all you're doing is just copying and pasting this content right there. And you're choosing something to talk about in this that's going to help guide your listeners to the development of your solution. All right. Next slide is project specifications. These are the things that it will do and what it will not do. And you probably want to pick some things on this that you can talk about, but you don't have to talk about everything. So this is the specifics of what your design is going to accomplish and what it's not going to be able to do. All right. Engineering concepts. This is where you connect your design specifications to STEM principles. And it can be as simple as this, where you have, hey, here's our what we're trying to do and how you would measure that with some physics. And then here's some formulas over here. So I've got a few in here. We're talking about weight and displacement, leverage, coefficients of friction, that sort of thing. And on like that. So these are going to turn into testing to make sure that our solution works, right? So that's what we're trying to establish here, connecting the specifications to physics principles or math concepts or geometry concepts, things that we can measure, okay? Things we can quantify. Once we complete the engineering concepts, we need to move on to the survey. What we did in our presentation, and this will be fine, just clip a picture of the first few questions and what the survey would look like that you sent to your users or your people you were getting feedback from. And then over here, list the specific questions. Good idea here is to talk about the questions that you got the most from, okay? Then you're going to go through the survey results. If you use Google Forms, then it makes these wonderful little graphs for you. And what you can do with each of these slides, you can talk about how that question led you to establish the design you had in mind or expanded your thoughts into new directions for your design. Okay. Case in point, we have one down here that showed that having something that was goat proof would be a benefit. So, but you'll just spend some time talking about your survey results. Again, what you want to do is connect that survey, that information to saying either, hey, our design specifications were on point, or we needed to adjust trajectory a little bit with our solution based on input from expected users and experts. Okay. After that, you're going to have your notebook sketches of what you plan to build. In this case, there were 3 people on the team, so we put all 3 sketches in here. So this is just going to be your initial thoughts, and then you guys built a model for me, and you were supposed to take lots of pictures of it to kind of flesh out some of the problems. Hopefully, what you found here is you've identified some places that were going to be challenging to actually construct, and that would be good stuff to talk about right here. And then we get into technical drawings. I would expect to see screenshots of your designs as assemblies and exploded views with parts lists. I would expect to see, so this is our isometric information here. And the exploded view helps us understand if it's got multiple parts and how they go together. Then the orthographics, I would say on this, don't go crazy with ANSI standard measurements. Just do a few basics like the width, the height, the depth, maybe like important angles. The 60-degree angle was very important to our design, so we kept that in there. But just do screenshots of your orthographics. Remember, it's top, front, right, and or top and then front and right. Yeah, so this is your front view, top and then right, and then the isometric on there that's also shaded. If you have trouble with this, let me know. So we've got some orthographics. You'll notice that what we have in our technical drawings and what we finally produced don't necessarily match. It's good if they do, but it is normal that you would have some deviation as you go through. So here are some other ones. This is a part we 3D printed. And so you can go through and talk about some of these the individual parts and what was challenging and maybe adaptations you made along the way, saying, hey, this structure wasn't like our actual structure. We had to modify up here to make it easier to set a motor on or something like that. Okay. And that's all for this video. And I'll see you again in just a moment.